All right, so we're going to look at a radical equation here. These are going to involve some quadratic formula here in a little while, but for now we're just going to focus on some of the easier ones. So the general scheme for solving these is that you want to get the square root part. This one has two actually, but you want to get the square root on one side of the equation by itself. All right. So now that it's already done for us here. Now that it's by itself, what we're going to do is we're going to square both sides. And what happens is your square root and your square just they undo each other. That's going to give us 2x plus 2 is equal to 5x minus 10. All right, and now we just move all of our variables over to one side. I'm going to move my 2x over here and move my regular numbers over to the other side. So I'll plus 10 there. So 2x can cancel, 10s can cancel. That's going to leave me with a 12 and a 3x. Divide by 3, and you'll get 4 is equal to x. Nice. Now, until you learn the ins and outs for how these things are actually going to work, what you should do is actually plug in your answer and make sure that the original equation balances. So take this 4, and we're going to plug that in for x. So on the left side, we're going to get 2 times 4 is 8, and then 8 plus 2. That gives me 10 on the left side. And then we'll do it on the right side as well. 5 times 4 is 20, and then 20 minus 10, that is also 10. And so, yay, the left side equals the right side. So we did good. All right, moving on. Sometimes that won't happen, and we'll see some of those later. All right, so for this one, what we want to do is isolate the square root. We want to get the square root part by itself, or mostly by itself anyway. I'm going to move this 2 over first. So move the 2 over. That's going to give me 5 is equal to 4 root 4 minus x. Now I could divide by 4 here. That would either give me like a decimal over here or an improper fraction. And then what would happen is I would square that, so I'd get kind of an ugly answer. You can do that if you want to. I'm just going to square it the way it is. So I'm going to go ahead and square both sides here. All right, of course, 5 squared is 25. On the right, we're going to square the 4, and we're going to square the square root part. All right, so it's going to be 4 squared is 16. And then when you square that part, you're just left with the 4 minus x. But because the 4 was being multiplied by this whole thing, well, now it becomes 16 is being multiplied by that whole thing. So I'm going to end up distributing here. So distribute. 25 is equal to 64 minus 16x. Subtract 64. Yeah, if you want to, you could subtract 64 from both sides. Okay. That's going to give me negative 39 on the left-hand side and negative 16x on the right-hand side. Of course, the negatives don't matter because you got 2 negatives there. Divide by 16. All right, so there's your ugly answer. X is equal to 39 over 16. What you would want to do from here, hopefully, is if you have a little calculator, is to check your answer with it. All right, so you could do 39 over 16 store to x. Remember the store button's down here. Store to x, and then you could just type in the right side and see if that equals the left side. I'll go ahead and work it out by hand just because. All right. So I'm going to type in the right, I'm going to do the right side, and hopefully I get equals 7. So 4, and it's 4 minus 39 over 16 plus 2. Okay, so 4 root 4 minus 39 over 16. I'm going to multiply my 4. It's a 4 over 1. I'm going to multiply top and bottom by 16. So I get 64 over 16. So this is still equal to 4. 64 divided by 16. I'm just writing it with a funky denominator, so that way I can actually subtract these two fractions. And then let's go with 64 minus 39. That's equal to 25 over 16. The square root of this, the square root of 25 just becomes a 5. Square root of 16 becomes a 4. The 4's can cancel, and then you just get 5 plus 2. And it does. It equals 7. And that's what we were hoping for. Yes. Awesome. All right, last one here. This video anyway. All right, so you come up to an equation like this. You're like, oh, it's so easy. I'm just going to go ahead and square both sides. So if I square both sides, this is going to give me 3x plus 15 is equal to 36. And you say, oh, that was so easy. I'm just going to minus 15 from both sides. And I get 3x is equal to, oh gosh, 21? Yeah, 21. So that means that x must equal 7, right? Wrong. All right, so if you plug in the 7, you're going to get 3 times 7 is 21. And then plus 15. If you work this out, you'll get square root of 36. And this is a little weird, but square root of 36 is not going to equal negative 6 here. So I know once upon a time, we talked about, when you take the square root of 36, it's equal to plus and minus 36. All right, so when you're doing radical equations like this, well, that won't be the case. And the reason why is because it has to do with, I guess it would be the range. It would have to do with the range of your square root function. So this particular square root function, it doesn't have a negative 6 in the range. So what that means is that there's no input that you can plug in that will give you negative 6 as an output. All right. Hold on for a second. All right, so here I've graphed the square root of 3x plus 15. And you see down here at negative 6, well, this function in red, it never actually gets down that low to the negative 6 marker. And so we're going to say that this function doesn't include negative 6 in its range. So that means there's not going to be a solution to this kind of equation. So, I mean, what this equation literally says is find the input so that the output of the whole expression gives us negative 6. Well, negative 6 is an impossible output for this function. All right. Negative 6 is not in the range, so it's not going to be possible. Basically, anytime that you're going to see with radical equations, if it ever gives you the square root of something equals something negative like this, you don't even have to try to solve it. I mean, it's impossible. All right.